Es ist ein junger Mann, der Arzt ist. Und ihr wisst ja, Ärzte werden gebraucht, vor allem in Brandenburg. Und er kommt fast aus Brandenburg, er kommt nämlich aus der Charité in Berlin. Ja, Applaus. Und ich möchte ihn hier auf die Bühne bitten, Vinay Rambal. Komm nach vorne. Was hast du gesucht, Vinay? Was hast du gesucht?
Gesucht jetzt, oder?
Ja, eben.
Ja, dieser Laserpointer.
Ah, ein Laserpointer. Er ist vorbereitet, man sieht es. Er ist technikversiert. Vielleicht kann ich mal fragen, apropos Technik, was höre ich eigentlich mit diesem Ding ab, wenn ich das mache? Nur Herzschlag?
Ja.
Und wenn der Arzt sagt, huste mal? Huste mal?
Es tut mir leid, ich bin nur so sicher, was Huste mal ist.
Was bist du?
Ich bin nur so sicher, was das bedeutet, denn mein...
Ah, okay. What does the doctor want to hear when he says, cough please?
Cough please, to hear your heartbeat.
Ah, I don't know. Vielleicht war mein Kinderarzt immer nicht so ganz professionell, wie es dieser junge Kollege hier vielleicht ist. Ihr habt es vielleicht mitbekommen, er kommt nicht aus Deutschland.
Ursprünglich nicht, aber jetzt, ich bin aus Berlin.
Jetzt ist er aus Berlin. Und weil er jetzt aus Berlin ist, wird er heute seinen Vortrag auf Englisch halten. Berlin, eine internationale Stadt, vieler Sprachen mächtig, auch des Englischen. Und deswegen wünsche ich viel Spaß mit Vinay Rambal.
So, guten Abend Leipzig. My name is Vinay Rambal and I'm doing my PhD in immunology, so immunology, at the BSRT or the Berlin-Brandenburg School for Regenerative Therapies. And so more specifically, I'm doing my PhD in transplantation immunology. So, and I'm dealing with the role of the immune system in the case of human organ transplants and in the case of kidney transplants. So when you transplant a kidney from a donor to a recipient, the role of the immune system in this case, that's what I'm studying. And through my presentation titled Do Two Negatives Make a Positive? Through this question, I would try to explain to you what I'm doing in my PhD, what kind of questions I'm trying to ask, and what progress I have made so far in my work. So let's begin. So let me begin by asking you, all of you, a very simple question. Imagine it's midnight. You are sitting in your living room comfortably on your sofa. Maybe you are a little sleepy or so, and all of a sudden, you see a stranger in your living room. How would you react? For instance, you, sir, how would you react? Vida? You would be afraid, yes. I would be afraid too. Just maybe one of the very possible reactions that one would have. And if I see a stranger in my living room who has this kind of an appearance, I would definitely get alarmed because I don't know who this guy is. I don't know his identity. Maybe he's an enemy of mine, or maybe he's a friend of mine. I don't know. Maybe he's a robber who is coming to steal something from my house. In this case, something like a radio, it seems. Or maybe he's a good guy. Maybe it's Christmas Eve. And it's Santa Claus who's come to give me some nice presents. So I don't know. Maybe he's my friend or my enemy. And which is why I would certainly get alarmed. And this is exactly what happens when you transplant an organ from a donor to a recipient, for instance, a kidney. Now, it's common knowledge that when you transplant an organ from one human to the other, the body of this recipient, or the immune system rather of this recipient, gets alarmed. But do you know perhaps why or how the immune system gets alarmed? So just as all of us have a fingerprint on our thumb, every cell on your body has its own fingerprint. But this fingerprint is called the major histocompatibility complex. Don't get a vocabulary complex, I would explain what this is. So, just as everybody has a fingerprint on their hand, every cell on your body, that means every cell that the body of the recipient and the host, and the body and every cell of this organ, it has this thing called its own fingerprint, which is the MHC. But this fingerprint is in the form of some molecules present on every cell of the organ. So shown here are these molecules which make up the thing called as the MHC. So it's kind of like a fingerprint which everybody has on every cell on their body. And it's quite special to you and it's quite unique to you, just like your fingerprint. In case you're wondering, this is not my signature, it's Barack Obama's signature. So what are maybe the components involved in this process of the immune system getting alarmed? So shown here are various cells that are made up or that make up the immune system in your body. A few of them are the CD4 positive T cell, the CD8 positive T cell. Perhaps you may have heard of these cells already in the case of HIV or so, because these cells are known from a very long time and they are quite well known from a long time. But quite recently discovered is this set of cells called as the CD4 negative, CD8 negative, or simply called as the double negative cell. Now, please keep this cell in mind, as I would focus my talk on this cell later. So as I said, this stranger, this ugly looking guy has entered into your body, and now your immune system has gotten alarmed. And this process is a very complex and dynamic process, as all these cells which I just showed you from the immune system, they all start screaming and shouting and yelling, and they are trying to decide what to do, because precisely they are also afraid and they are now trying to decide what they should do. So there are lots of cells, and some of these cells say kill, kill, kill. And that's because these cells say that this guy is my enemy and we must attack it. Whereas, there are some cells which say, come here my Meshusa, give me a hug. Maybe something from my personal experience, but that's what the cells say as well. Now, this is the scenario which happens quite often in the clinic, which means that the cells which say attack the organ are predominant over the cells which cause acceptance of the organ. Now, if I'm a patient who has received an organ transplant, and if my doctor shows me this, I would maybe die of a heart attack before dying of the operation. So this is a very bad scenario which might occur in the clinic. And therefore, what we want in the clinic, ideally, is this scenario, in which we want these cells which cause acceptance of the organ to predominate in the body after the transplantation. And that's exactly where these double negative cells come into the picture, as it was shown quite recently that these cells perhaps may be having a property by which you can accept the organ. But this was shown only in some mouse models or some experimental mice. Maybe they don't look like this, they may perhaps more look a little bit like this. But we don't know too much about these cells, but they were just it was shown in mice. How did we know that they may perhaps be capable of causing acceptance of the organ? So when some donor mice gave an organ to the recipient mice, as expected, the recipient mice attacked this organ. But when the donor mice gave an organ to the recipient mice, and along with this, we gave some double negative T cells to the recipient mice, these mice accepted the organ, and therefore we had some idea that these cells are perhaps capable of causing acceptance of human organs, and we may perhaps use them for some kind of therapy. So, which is why this is a very interesting topic of research to focus on, and that's why what my PhD basically deals with is to try to find the properties of these double negative T cells. So what kind of chemicals do they secrete in the body? Their numbers after transplantation in human beings. So after you transplant the organ, how does their number, does it increase or does it decrease in the human body? We do not know this in humans, as there is just some little data from mice so far we have. So basically what I do is I receive blood from patients, and I receive blood at different points of time, so 1 month after transplantation, 2 months after transplantation, and so on. And at these time points, I analyze in the blood the presence of these double negative T cells. So the results which I have so far and the progress that I have made so far is as follows. It was seen that the number of these double negative T cells in these patients increases after transplantation, which is kind of a good news because we now know that this means in humans they have some kind of role to play in transplantation and maybe they can cause acceptance of human organs. But surprise, surprise, as it happens in research, I found out that these cells can also secrete a chemical called as interferon gamma. Now interferon gamma is actually a bad chemical which which might cause the rejection of the organ. So we still need to do a lot of research in this to figure out if these cells actually can or cannot cause acceptance of human organs. In the end, I would like to say that we know in mathematics, 2 negatives make a positive. But in human organ transplantations, whether these double negative cells equal a positive outcome in patients, we still have to find out. Thank you.